print BST elements in given range. So given a binary search tree and a range low, high, we need to find all the numbers in the binary search tree that lie in the given range. We are given a note that element greater than or equal to the root go to the right side. So element greater than or equal to root go to the right side. So what actually a binary tree? So suppose we are having binary tree like this. Okay, and some there is some values, and this is our root. In a binary tree, all the values that are less than the root will lie in the left, and all the values that are greater than the root, this time root will be less than the left right. So all the values that are greater than the root will lie in the right hand side. So this is what a binary search tree is. So we will be given a binary search tree. So here let's check here itself. Like here it's 17 is the root, and when we check the left part of this 17, we see 4 2 9, that values are less than 17. Now if we look to the right hand side, we see 18, which is greater than 17. So that's what here what I said, that all the values that is less than the root will lie on the left hand side, and all the values that are greater than the root will lie on the right hand side. So that is BST. So along with the binary search tree, we will also be given a low value and a high value, and we need to print all those elements. We need to store all those elements that are in between this low and high inclusive. So if we check here, the range is given 424. So if we check 17 is in between 4 and 24. So 17 must be included. If we check this 4 is between 4 and 24. So 4 must be included. If we check this 18 is between 4 and 24. So 18 also must be included. Now if we check 2 is less than 4. So this 2 will not be included. Now 9 is in between 4 and 24, so 9 will be included. Same way the next example, our low value is 13, high value is 23. So we have 16 is in between 13 and 23, so 16 must be included. Now we check for 7 it's less than 13, so 7 must not be included. Now when we check for this 20 is between 13 and 23, so 20 will be included. Now 1 is less than the low value, so it will not be included, and 10 is also less than the low value, so it will not be included. So in this case only 16 and 20 are the values. So what we must do here? So typically we need to traverse this binary search tree and check whether each of the value lie in between this low or high. So if it lies in between this low and high range, then we can include it in our result. Otherwise we need to continue searching it left or right. So that's our intention. So that's what we need to do. So there are typically 3 types of traversal. One is Inorder Traversal, where our traversing arrangement is like a left, then we will print the root, then go to the right. And the next one is pre-order traversal, and its arrangement is first root, then left, then right. The third one is post order traversal, and it is left, then right, then root. So these are the three types of traversal available. So here the best will be the in-order traversal. So how in-order traversal will help us? So let's take an example. Let's take this example. Okay. Okay. We can draw. So this is 16 and 720 one time. Then here we have 7, here we have 20, then we have 1, we have a 1, and we have a 10. So during in-order traversal, what happens means, from this 16, that is from this root, first we go to the left, then we check, then from this 7 we again go to this left. Now from this 1, this one is null and this one is also null, so we just go to here, we see that it is null, so we come back to this one and we'll print 1. Now we check with the right is also null, so we get back to 1, and 1 is already processed, so we get back to 7. Now 7 will be processed. Now we go to the right side of the 7 and it is 10, and from 10 we check the left hand side, but left is null, so we go back and we have the 10, and we look for the right, and right is also null, so we come back and 10 is processed, we go to 7 is processed, we go to 16. Now we print 16, and then we go to the right hand side. So right hand side is 20, so from 20, as keeping it as the subtree's root, this is we go to the left is null, so we go back to 20, so this will be 20, and from 20 it go back to right, but right is also null, so we get back to this one and we get back to this one. So the in-order traversal of this tree will be 1, 7, 10, 16, 20. So from this, while doing this, we can check for the low and high values. So these are the values that we need to check, that is low is equal to 13, h is equal to 13. So same way, so low is equal to 13, high is equal to 13. So 16, 7, 20, 1 and 10, 1 and 10. So in-order traversal, we start from this root, that is 16. This is our root 16. We go back to we go to the left. Here there is a left or right child, so we go to the left, and there is 1 here, it's null, and this is also null. So we check whether this one is in between 13 or 23. So the first condition, 1 is in between 13 and 23, and it's no. So this one will not be considered. So from here we go back to this one, we check with the right is also null, so from right we again reach back to this one. Now 1 is already we processed it, so we go to 7. Now we check whether 7 7 is in this range. 7 in between 13 and 23, and it is also no. So we will not print this 7. So from this 7 we go to the right side, and to the right side we have 10, and to the from 10 we check with the left child, we check with the right child, we check with the left child, it is null, so we go back to 10 and we check whether 10 is in between. So third one is whether 10 in between 13 and 23, and it is also no. So we then check the right hand side is null, so we go back to 10 is already processed, we go back to 7 is already processed, now we reach 16. Now our next checking condition is 16, so our fourth one is 16 in between 13 and 23, and the answer is yes. So in our answer 16 must be included. Now from 16 we go to the right hand side, that is 20, and from 20 we go to the left and right child. Here left is null, so we get back to 20, and now we check whether the 20 in between 13 and 23, and it is also yes. So 20 must also be included. Now we go to the right hand child, it is null, we get back to 20, and then we get back to 16. So only 16 and 20 are the result, so we must return this result 16, 20. So this is what we need to do. So the first condition that we are checking is whether the root is already null. If the root is already null, we can just return an empty array list. Okay, so if the root is null, an empty array list will be returned. Now we need to store, here the return type is array of list, so we need a variable in order to store these values. So array list of integer, we can say that result, which is equal to new array list. Now we need to fill the result, and we pass our root, our low, our high. So fill the result is the helper function. Fill the result is the helper function which will do the in-order traversal and pick all the values between low and high. So after we are done with this one, our result, this array list will be occupied with the result what we needed, and we can just return this result. So now let's write our helper function, public static void. It is not returning anything, so public static void fill the result of node int low int high. So if our just checking, since this is here we are doing recursion, so we need a base condition in order to exit the recursion. So this is the base condition. If node is null, then we just return. Otherwise, what I told, we need to go to the left, then check for the condition, that is the print the root, then to the right. So first we will go to the left. So node dot left low high. Now we need to check whether the node dot data is greater than or equal to low, and then node dot data is less than or equal to high. So here we check whether the value is in between the given range. So if node.data is greater than or equal to low and node.data is less than or equal to high, then we will add it into a result. So result.add of node.data. Here I found a mistake that I also need to pass this result. So let me add that result also into the function call. So here also result. So to this result, the current node.data will be added. Now, so this is move to the left. This will print. Now move to the right. So fill the result of node.right comma low comma high comma result. So after completing, we will after traversing the whole tree, the result will be occupied. So if we check this value also, at first we check whether node is equal to null. We are at 17. 17 is not equal to null. So we go to the left side. 4. We check whether 4 is equal to null. No. So we go to 2. We check whether 2 is equal to null. No. We go to the left child. So that value is null. So we will return back to this 2. Now we check whether 2 is greater than or equal to low and node.data is less than or equal to high. No. So we go to the right hand side. So from 2 we go to the right hand side. It is also null. So we return here. So from this also we return back to 4. Now we check whether 4 is greater than or equal to low. Yes. And 4 is and 24 and 4 is less than or equal to high. Yes. So 4 will be added. Then we move to the right hand side, that is 9. So 9. From 9 we go to left hand side. It is null. So it will be returned back to 9. Now from 9 it is in between low and high. So 9 will be printed and we it go to the right hand side. So right hand side is null. So it get back to the 9 and 9 is already processed. So we go to 4. 4 is processed. We go to 17 and 17 and 17 will check whether node.data is greater than or equal to low and node.data, that is 17 greater than or equal to 4, 17 less than or equal to 24. Yes. So 17 will be added to a result. And now we go to the right hand side, 18. From 18 we go to the left hand side of 18, which is null. So null will be returned. It will be returned back to 18. Now this 18 will be checked with the low and high condition and 18 will be added to a result and check with the right hand side. Right hand side is null, so it will be returned back and it will be finally returned back. So this is what happens with this example. Let's run this to check whether there is any compilation error or any error. So 4, 9, 17, 18. So that's what we are getting the answer. So when I run it, yes, it's accepted. So considering the time and space complexity here, time complexity will be big of number of nodes. So big of n, where n is equal to the number of nodes, because we are doing Inorder Traversal and we are traversing through each and every elements in the binary search tree. Now the space complexity is big of height of the binary search tree. And here also we are using a result array, but it can hold the whole elements. So the space complexity will be big of height of the binary search tree itself.